Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, so I'll make this quick because it's already late. So we're a community project, I already said this, so we want to build our community. One way to do this, I start with the last point, is we started organizing workshops and events, and this is a lot of fun. I really recommend this to people in general. I think some other projects also do this. Stan recently had the first meetup in London. And we're currently applying for a grant, NumFocus, to organize a code sprint next year, where we get together all the developers from all over the world. I mean, maybe most projects here have all the developers in one group, but we don't, so it's super nice to get together. Another thing we would love to, this is kind of a dream, we just founded a non-profit association to be able to take donations and maybe hire a developer in some sense. This would be great because we have lots of problems that need kind of long-term love. And we also, I mentioned this earlier, we're trying to change our license. This is hard. And another thing, since we're having all these, we've piled up all these algorithms, Shogun can be very useful, I think, for education and machine learning at universities, because we can easily compare different methods and visualize things. So we want to push this. So currently I'm talking to kind of the people that teach in London to use Shogun for the machine learning courses. We hope to get this going, and together with these IPython notebooks, and that's the thing we want to do. Then so the code sprint will mainly be, that I mentioned, will mainly be on technical goals. So people have been talking a lot on technical goals here. Well, we share most of them. So first problem with Shogun is we have this super complicated build process because we support all these languages in these interfaces. So it's hard to compile it, hard to install it. This really needs to be resolved for this. So this is one thing we really want to focus on having like easy installation and procedures that all these Python projects have. We just type in pip install Shogun. This would be amazing. Then we have a bunch of like internal, because the framework is really old, and as code gets worse and worse when it's older, we need to clean up things, reduce memory footprint and stuff. And then this here is maybe the biggest thing we have in mind, is we want to generalize over the internal ways to compute things. So the first baby step towards this is to have an internal representation of linear algebra operations, but we don't want to be another library to do linear algebra operations. We just want to be independent of the backend. So since I'm in Shogun already, we switched from LAPACK to Eigen, and now there's GPUs, so we don't want to change like all the algorithms again. We just want to interface against some internal representation that is independent of the backend, so that we can easily change the backend to be sustainable in a way. And we want to do the same thing for parallel and distributed computing. So we've already started kind of coming up with internal representations of how can we represent computation jobs, tasks that are done without dealing with a concrete interface, so that we can easily select between, well, we want to do things some kind of shared memory, or we want to do it on a computer network, on things like batch clusters or Spark. I think this is a very useful thing. And also I think this is a great opportunity for collaboration, because most open source projects have this kind of, they have the same problem. They have some computing tasks, and they somehow, without changing the algorithms too much, want to be flexible in where the stuff is executed. So I think this is maybe there could be some kind of meetup project that provides a basis for computation in all these projects. And this slide, I just wrote it. So I'm super excited. I would love to interface to lots of projects here. So kind of, there's the Stan project, and it would be cool if we could use the fixed probabilistic models from Stan within Shogun, could expose them, would be good for them. We have already bindings to VW and liblinear. We'd like to update, for example, the VW one. So this would be nice to talk to about. This libgpu array looks super cool, so we'll have a look. We kind of, with this matrix view problem, we haven't really solved it in a satisfying way. And also we can, through all these interfaces, we can embed high-level languages into our project. We can call this stuff from C. So if you're interested in exposing your models through Shogun, talk to us. We might do it. And this is the thing I mentioned in the discussion. So last year I was last October I was at Google for the Google Summer of Code Mentor Summit, and I met this other guy also from a machine learning toolbox called MLPAC, and he just released a paper on how much faster his toolbox is compared to other toolboxes. And what he did, he built this super cool framework where he compared his toolbox to other toolboxes on standard problems, all in an automated way. And one vision I kind of have is, imagine you had a website and every toolbox for a certain problem can upload their script, and then everything is executed and compared. And so this way you create reproducible benchmarks. This is good. And also it has a really nice motivation part, because so me as a library, I'm interested in, being fast. So I tune my scripts. So usually when, in papers you compare methods to each other, you tune your own methods, and about the other methods you don't give a shit, you tune yours until you're faster. So then you would have some kind of framework where where everyone is interested in making a good impression, and then you can look at it. You can see like, okay, I have this much time, this library is this accurate, this library crashed, this library uses too much memory, and so on and so forth. I think this would be amazing. So we are trying to push this. It's a bit hard to do this alone, but if anybody's interested in this, so we're offering one of these Sum of Code projects next year. We tried it this year, but we kind of ran out of time. And we're already collaborating with this other guy I mentioned who has started on this, so maybe this would be a really nice thing to do. And that's it. Thanks. Yes?
On the last point, we did some comparison of Theano again on the software, and in the past, before the current one, it's one lab that take the software, make it work, take the other one you want to compare, try to learn them, implement the same implementation, do the comparison. Doing all that with all the installation problem, linking with BLAS, optimization version, it's very hard to do on many different systems. In the current benchmark on the convolution that we talked a few times, what is happening is it's mostly the author or user of each system is providing some support to the people that do the benchmark. They do their own for Torch, because it's mostly Torch developer that started that. From Theano, it's Theano people that do it. For some of the other systems, they have started it, or they have done it, or sometimes they have help from them at the same time. So if everybody do the work for their own, first you have that collaboration, it makes it easier for everybody. I don't know how to reproduce that collaboration in other case. I'm not sure why it worked this time and not in the past. At first, in the past, we never tried, and it wasn't on GitHub, so it was more difficult. But
well, technically, you could set up a fixed environment and tell people, okay, you have to write a script that runs your algorithm, and you deal with the problems. You just get the data, and we just get the results. And then we compare, and kind of people are responsible for this, and you kind of take some standard, Ubuntu long-term support system, and if you can't make your toolbox work on this, then, well, it's your problem.
So MLComp tries to do something like that. Basically, they'll launch a VM for you. And
yeah, exactly. Yeah, I know there's also the MLOS project. Sorry. Yeah, there's MLOS and MLData. So MLData is this open source machine learning data sets thing that's kind of, they're meant to be benchmark data sets, but it's kind of dead by now, which is really sad. And MLOS is this open source track of GMLR where you can submit your project. So within these things you could think about this. But nobody's really doing this. Even, these websites like MLOS, it once the guys stopped doing it because they had a child, it just died.
Yeah, my impression is people have tried to do the last one several times, and it hasn't quite worked.
Yeah.
And pinning down exactly why it hasn't quite worked is kind of subtle.
Yeah, I agree. I mean, this goes further than just ML toolboxes. This is also super important for reproducible research in my eyes. When you have all these papers about, classification algorithms, and everyone always claims, we beat everyone, but there's actually, the benchmarks are always biased because your new sampling algorithm, and so it's ridiculous. There should be some framework to compare things in a neutral way. Yeah.
Can I add something that I think is really important here? A lot of these learning methods have hyperparameters to them, like a learning rate or an annealing schedule in something. And I find it's very hard to compare these algorithms when somebody's taken the time ahead of time to find the optimal versions of those, and then that's what you're comparing. Because that doesn't really represent the practical situation where you're facing new data and you have to spend a lot of time. Like, at least for the SGD versions we wrote, it would often take as much time to find the right hyperparameters. Then once you found them, everything ran really quickly.
Yeah, that's actually, I mean, that's true. So, so the initial work that was done here was actually separate implementations of the same model or algorithm for the same model, so same parameters. So you fix the parameters for your, don't know. But once you start comparing like families of models, then that's a problem, obviously, yeah. I agree.
It's a problem even if you're trying to test your own project.
Yes.
Because you're overfitting your own tests.
At some point, I think that the automatic hyperparameter selection is a way to remove that bias. Again, someone that manually tuned it during six months to get the best hyperparameter. But until we have automatic hyperparameter selection, I think it will be pretty hard to find something like that. So if you implement that part, I think it will be a must for that to have a chance of success.
Yeah. Maybe, first step is there are multiple frameworks for deep learning. So you take a model, you fix the parameters, and you run different implementations. And then already in there, you will see divergence in the results, both runtime and results. So this would already be an interesting one if you fix these things, I think at least. Yeah.
You can get around a lot of the installation problems by just making like an API and communicating over like SOAP or XML or RPC or something like that. Coming up with that kind of design of what that the API should be there seems like something that you, the Shogun guys, have thought a lot about, like how to make things glue together nicely and whatnot.
I agree. This is a problem of manpower, and this can't be done by one project. I feel multiple people would have to sit together and contribute time.
Earlier we were talking about Docker as a way to, we've been doing these experiments where like 6 lines of Docker config will launch an instance, install VW, including all the post dependencies, get everything compiled, run something, get the result, and just destroy the whole thing.
Yeah, that's true. We use Docker too for our notebook server. Yeah, okay, thanks.